Okay, so our next unit is dealing with radicals. Radicals are square roots, cubed roots, fifth roots, seventh roots, as high as you could go. What we're only going to deal with is square roots. Okay, and we're going to learn how to simplify those. So before we would be able to, see something like a square root of 4, and we know right away that's going to be 2. Well, sometimes we're going to have numbers that aren't perfect squares like that, but you could simplify them. Like the square root of 20. We could actually make that into a smaller form. Okay, so what I did was I created a perfect squares list for you. So everything on the right side is perfect squares. We know how to take the square root of those, right? 1, 4, 9. The square root of 9 is 3. So I gave you the root right here. That's 3. 16, the square root is 4. 25, the square root is 5. We could keep going down the line, so on and so forth. So I highly recommend that you use this chart when you are doing your homework and a calculator. Okay, and I listed out the steps for you, and I'm going to explain these steps as I go through the examples. So, example 1, I have something like the square root of 45. Okay, this could actually be broken down into something smaller. What that means is there's a number inside of 45 that is a perfect square. There's a number in there that I could take the square root of. So what you're going to do is you're going to think of numbers that multiply to be 45, and you're going to look at this list, and you're going to look at the right column, and you're going to look at numbers like 1, 4, 9, 16, 25. You're going to go down the line, and you're going to ask yourself, do any of these perfect squares, any of these numbers on the right column, go into 45? Well, I see one right away. I know that 9 goes into 45. What I mean is I could divide 45 by 9 and get a whole number, right? So what you're going to do is you're going to split up 45 into 9 and whatever multiplies by 9 to make 45. Okay, so that's what step 2 means. Split up the number into the perfect square and that factor that multiplies to be that number. So I'm going to break up 45 into the square root of 9 times 5, right? Because 9 times 5 is 45. Now, I know how to take the square root of 9. So you could actually split this up like this. The square root of 9 times the square root of 5. Okay, that's saying the same thing. So what I'm going to do is take the square root of 9. I know that that's 3. And what I have left is the square root of 5. And then you're done. That's your final answer. And the reason why I know I'm done is because there's no perfect square that goes into 5, right? The only things I multiply to be 5 are 1 and 5. Well, I could take the square root of 1, but I could keep doing that over and over and over again, and then I'll never be done. But 5 isn't a perfect square, and so that's it. So the square root of 45 is actually the same thing as 3 square root of 5. Okay, so let's try that again. So number 2, 18. So I'm thinking of perfect squares. What perfect square can I, what perfect square goes in 18? Well, I know that that's 9. 9 times what gets me 18? 9 times 2. Okay, so this is actually the square root of 9 and the square root of 2. You could write it this way because 9 times 2 is the same exact thing as 18, but I know I could take the square root of 9, that's 3, and I cannot take the square root of 2 because that's not a perfect square, so I'm going to leave it as the square root of 2. Okay, 2 is not a perfect square, contrary to what some people might think. Okay, so this is your final answer. So the square root of 18 is the same as saying 3 square root of 2. Okay, moving on. Number 3. So I have a number outside of this radical, and I'm going to ignore that for right now. Okay, what I'm trying to do right now is look at the 200 and think, well, what perfect square goes into 200? So if you can't find that, go to your list and start with numbers that are lower than 200 and start dividing 200 by 196. Do I get an even number? No. 200 divided by 169. Do I get a whole number? No. 200 divided by 144. No. Okay, keep going, keep going. 200 divided by 100. Yes, I know that that is 2. So what I'm going to do is rewrite this as the square root of 100 times 2. Now, you don't have to take the separate step to write it as the square root of 100 and the square root of 2. Okay, you can leave it like this. And what I want you to do is leave that negative 4 outside of that square root. So what I want you to do is to take the square root of 100, which is 10. So the 100 is now gone. Okay, it is not in that square root anymore. And I'm going to bring that 10 out. And that 10 has to multiply by that negative 4 that's already out. Okay, what's left is just the 2. So a lot of people try to leave a 10 inside of the square root, which is not the case. I'm taking the square root of 100. There's nothing left inside of that 10 or that 100. It's just the 2. And then multiply the 10 by the negative 4, and I get negative 40 square root 2. And that is your final answer. Okay, number 4. So we talked about this in the first semester when we were taking square roots of variables. But I want you to write this now. A variable is a perfect square if the exponent is even. And we've done this before. And to take the square root, square root of even exponent, you divide it by 2. Okay, so a variable is a perfect square if the exponent is even, and if it is even and you take the square root of it, okay, all you have to do is divide your exponent by 2. So right now, when I want to simplify this, ignore the 2 on the outside, just keep it on the outside, and let's split up 48 into a perfect square times some number. Okay, so again, if you can't find the perfect square that goes into 48, go in your list and start with numbers that are smaller than 48. So 36, and type in your calculator 48 divided by 36. What do you get? A decimal. Okay, move on. 48 divided by 25 doesn't work. Okay, move on. 48 divided by 16. Now in your calculator, you should have gotten 3. So that means 16 goes into 48 3 times. So I'm going to split this up into 16 times 3, and I'm going to leave that n to the 4th. And what you need to do is take the square root of every perfect square. Okay, so leave the 2 out there, and the other perfect squares that come out are going to multiply by that 2. Well, I know 16 is a perfect square, so the square root of 16 is 4. And I know n to the 4th is a perfect square because 4 is an even exponent. Now to take the square root of that, all you have to do is divide the exponent by 2. So 4 divided by 2 is 2. So that's going to become n squared, and that is no longer inside of that square root. So after you cross all of that out, I see I still have a 3 left inside. So that's got to stay in there because that's not a perfect square. So I need to multiply what I have on the outside. So 2 times 4, that's 8, n squared, square root of 3. And that's your final answer. Again, you know you are done because you look at the number on the inside and ask yourself, is there a perfect square that I could divide into that number? Well, the only things that multiply to be 3 are 3 and 1, and 3 is not a perfect square, so then you're done. There's no other perfect square inside of that number other than 1. Okay, number 5. Again, we're going to leave that 2 out. 36 is actually a perfect square, so I'm not going to worry about the 36. I don't need to fix that because I could take the square root of that. But notice that n to the 3rd is not a perfect square. but there is a perfect square that lies within n to the third. And so watch what I'm going to do. I'm going to change n to the third to n squared times n to the first. And let's think about why I can do that. Let's go back to our exponent rules. If I were multiplying exponents, let's say n to the fifth times n to the sixth, what do you do to those exponents? Remember, when you're multiplying, you add those exponents together. So I could actually split up n to the third into n to the second and n to the first, because 2 plus 1 is 3. So when I multiply these two together, you get back to this. So those are saying the same thing, but I'm creating a perfect square with the n squared because I'm creating an n with an even exponent. So the trick with variables is just make it one less. So since it's n to the third, one less than that is n to the second times 1. Let's say that was n to the fifth. I would make it one less. So n to the fourth times 1. If it was n to the 10th, it would be n to the 10th. Or sorry, that's an even one. If it was n to the 11th, I would take 1 away, so it would be n to the 10th times n to the first. Okay, so I'm going to take the square root of every perfect square inside of that square root. So the square root of 36 is 6. So that's coming out and has to multiply by that 2 that's already out there. Now I have an n squared. Since that's even, divide the 2 by 2. So it's going to be n to the first. And the only thing that's left is the square root of n to the first, or we could just say it's the square root of n. Multiply your big numbers on the outside, so I get 12n to the first, or just n, and then the square root of n. And here is our final answer. Okay, number 6. So I'm going to ignore the -7. That's going to stay out there. And then I know that 72 is not a perfect square. So I'm going to go to my perfect squares list. I'm going to start with numbers less than 72, and I'm going to start dividing with my calculator. So I'm going to do 72 divided by 64. That doesn't work. 72 divided by 49. That doesn't work. So then I'm going to do 72 divided by 36, and I end up getting 2. Okay, so 72 can be split up as in 36 times 2, with 36 being my perfect square. And then you're going to move to your variables. Now, do you need to fix this with the x? No, because that's an even exponent. So that one's actually a perfect square, so I don't have to split that one up. But I see here with the y, that's odd. Okay, so what I need to do is I need to split that up into a perfect square times a non-perfect square. So that's going to be y, and like I said, it's always one less, so it's going to be y to the fourth times y to the first. Every single time you're going to be multiplying one less than your exponent times 1. Okay, so I'm going to underline all the perfect squares. That's because these are even, and now I have to multiply whatever is going to come out of my square root by that -7. So I have to take the square root of 36, that's 6. X to the 12th, remember you divide your exponent by 2, so that becomes x to the 6th. And then y to the 4th, that becomes y to the 2nd. And then inside of the square root, I have 2 and y left. So let's multiply the outside numbers together. That's -42, x to the 6th, y squared, square root of 2y, and know the order of your variables does not matter. Okay, and then we're done. Okay, number 7. So notice that there's a negative outside of there. That's just saying that there's a -1. Okay, there's an invisible 1 behind that negative. I know 16 is a perfect square, so I do not need to split that up. I'm going to keep that as 16. X to the 4th, that's even, so I could keep that, but I have y to the 5th. So I'm going to break that up into y to the 4th times y to the 1st, and z to the 11th. So it's always one less than the exponent, so I got to split that up into an even exponent. So z to the 10th times z to the 1st. Okay, now I got to take the square root of every perfect square. So this is a perfect square, this is a perfect square, this is a perfect square, that's a perfect square. So -1 times the square root of 16 is 4. Square root of x to the 4th, that's x squared. So I'm dividing my exponents by 2. The square root of y to the 4th is y squared. And the square root of z to the 10th is z to the 5th. And inside of the square root I have left y and z. Okay, be careful when you're taking the square root of big numbers like this that you're not dividing by 2. A lot of people make that mistake because that's what you do to the exponents, but we only divide the exponents by 2 and we're taking the square root of the big numbers. Okay, so on the outside of my radical, this becomes -4, x squared, y squared, z to the 5th, and then the square root of y, z. Okay, and then number 8. So let's say we have big numbers like 128 and you can't find the biggest perfect square that goes into 128. You could find smaller perfect squares and keep simplifying from there. So for example, let's say I'm looking at 128 and I divide by 4 and I see 4 goes into 128. So 4 is another perfect square. So I could split 128 up into 4 times 32. Okay, and then I'm going to look at my variables. Well, this is odd, so I have to change that into an even exponent and an odd exponent. So m squared times m to the 1st, p to the 4th is already even, so I don't need to touch that, and q to the 1st, you can't split that up, so that's just going to stay as is. I know it's odd, but you can't get smaller than q to the 1st, right? So you just kind of have to leave it. And so let's start taking out our perfect squares. Here's a perfect square, here's a perfect square, here's a perfect square, and all of those are going to multiply by -4. So the square root of 4 is 2. Square root of m squared is m. Square root of p to the 4th, that's p squared. Now I have no perfect squares left to take out. So what's left inside is 32 q. Okay, multiply your outside number, so that's -8 p squared, square root of 32 q. Now, since I didn't find the biggest perfect square, okay, you have to check. So you have to check what's inside of your square root and ask yourself, is there a perfect square that goes into that number inside of the radical? Well, because I didn't find the biggest perfect square, there's still a perfect square that goes into 32. And that's okay. We could keep simplifying. So I'm thinking to myself, what's another perfect square that goes into 32? So I'm going to go back to my list. I'm going to go start with numbers less than 32. I know that 25 doesn't go into 32. I know 16 does go into 32 2 times. So I'm going to keep the outside the same. But I know on the inside I could then change 32 to 16 times 2 q. So I can now take this 16 out. So the square root of 16 is 4. Remember, you have to multiply the 4 by whatever outside of there. And what's left is 2q inside. So multiply these together. I get -32 mp squared, square root of 2q. So again, if you don't find the biggest perfect square, you could just keep breaking it down into smaller and smaller perfect squares until you finally have nothing left that you could pull out from the inside. Or you could take it the other route and go down the chart like I'm teaching you, using your calculator to find the biggest perfect square that goes in there, so you don't have to use so many steps. Okay, right now I want you to pause and I want you to try 9 through 12 and then come back and check yourself with my work. Okay, so in number 9, the biggest perfect square that goes into 150 is 25, and 25 times 6 is 150. So I'm going to take the square root of 25, that's 5, so it's got to multiply by that -5 out there, and I have the 6 left inside. Multiply the 5's together, so I get negative 25 root 6. Okay, number 10. A perfect square that goes into 32 is 16, so that's 16 times 2. K to the 4th is already a perfect square, so I'm going to not fix that. So these are my two perfect squares coming out. So the square root of 16 is 4. The square root of k to the 4th is k squared. And then I have 2 left inside. Multiply your outside numbers together. And you should have gotten 20k squared root 2. Number 11. 25 goes into 75 3 times. And I don't need to fix m squared or n to the 4th because those are both even. So square root of 25 is 5. M squared is m. N to the 4th is n squared. And what I have left inside is 3. So 35 mn squared, square root of 3. Okay, lastly, 96. So again, if you couldn't find a perfect square, the biggest perfect square, you could have used smaller ones, as in like 4, if you wanted to use 4. So let me just show you if you used the other method. So 4 goes into 96 24 times. P to the 9th, so that's not even, so I got to change that to p to the 8th times p to the 1st. Q is already even, so I'm going to keep that the same. And this is not even, so I'm going to change that to r to the 6th times r to the 1st. So let's take the square root of all of our perfect squares. Remember, it's all got to multiply by that 2. So the square root of 4 is 2. Square root of p to the 8th is p to the 4th. Q to the 8th is q to the 4th. R to the 6th is r to the 3rd. And inside we have 24 PR. Okay. I'm going to rewrite this. And 24 still has a perfect square in it. And that's 4, right? 4 times 6 is 24. So I'm going to take the square root of 4. You got to multiply by that 4 on the outside. So that's 8 p to the 4th, q to the 4th, r to the 3rd, square root of 6 PR. And no, there is no perfect square that goes into 6, as many of us believe. Okay, so that is actually your final answer. Okay, last part. Sorry, I know this is a lot. These last few lessons are going to be a little bit longer because since we're running out of time, I kind of have to condense everything together. But we're going to be adding and subtracting radicals. So, when you're adding and subtracting radicals, you need to have like radicals. Okay, so like radicals are radical expressions that have identical radicals. So the inside has to match exactly. So I gave you some examples. These are like radicals because inside they both have 3x. These are the same because they both have 7x squared y on the inside. And the number on the outside doesn't matter. Okay, so non-examples would be something like this because this has a y squared and this one just has a y, so those are not the same. This one has an x squared, this one has an x, those are not the same. And even though these two have the same number on the outside, one has an x, one has a y, those are not like radicals. Okay, so it's actually pretty easy to add and subtract when you have like radicals. So literally all you have to do, since these are both exactly the same, you just combine the numbers in the front. So this is like saying 7x plus 2x. I know that's equal to 9x. It's the same exact thing, except instead of having an x, you have a square root. So it's going to be 7 plus 2, that's 9, and then the square root stays exactly the same. Just like here, the x stays exactly the same. It doesn't become an x squared. Your radical is going to stay exactly the same. So in number 2, these are all the same, so I can combine all of the coefficients, the numbers in the front. Remember, there's an invisible 1 there, so I'm going to do 6 plus 1 plus 7, that's 14, and the square root of 2, is going to remain unchanged. Okay, number 3. These match, so I'm going to combine the numbers in the front. So 6x minus 2x, that's 4x, and the 3x is going to stay exactly the same. Do not combine the insides. Do not combine the insides. Okay, number 3. So you can only combine the like radicals. So I'm going to combine these two together because they both have root 3. Only the numbers in front though. So 8 minus 5, that's 3, and then the root 3 is going to stay the same. And then I'm going to combine 6 root 2 and negative 6 root 2. Well, 6 minus 6, that's 0. Then there is no square root left. A lot of people like to say, oh, there's still a root 2 left. No. That's like saying I have 2 root 2's in my hand, and then somebody comes and grabs all of the root 2's out of my hand. How many do I have left in my hand? Well, 0. I don't have any root 2's left in my hand. There's 0. I can't write root 2. Okay, these completely cancel each other out, and you're just left with the 3 root 3. Okay, so if the front numbers cancel out, they create a 0, then there's no radical left. Okay, it's gone. Okay, quickly with number 4, I just want you to try to combine those. Check with me. So I'm going to combine 9 root 5 and 6 root 5 because those are the same. So 9 minus 6, that's 3. Root 5 is going to stay. And then negative 2 root 3 and 7 root 3. So 7 minus 2, that's positive 5. And the root 3 stays the same. And we cannot combine these because they are not like radicals. So you just leave your answer as is. Okay. The last few examples, so when we're adding and subtracting unlike radicals, what you need to do is you need to simplify your radicals to see if you have a like radical. Okay, so right now these are not the same, but I do see that I could simplify this right here. So what I'm going to do is I know a perfect square lies within 12, right? That's the square root of 4 times the square root of 3. So that radical is actually going to become, well, the square root of 4 is 2, root 3. Well, now that I've simplified the square root of 12, these are now like radicals, and I can combine those. So 7 plus 2, that's 9, root 3. So what you need to do is simplify the radicals where you can. So with number 2, I know I could simplify 24 because I know there's a perfect square that goes into 24. So 3, and I could split this up into 4 times 6. This one I cannot simplify, so I'm going to leave that. And 54, I know I could split that up into 9 times 6, right? 9 is a perfect square that goes into 54. So let's simplify these. So the square root of 4 is 2, so that 2's got to multiply by the 3, so I get 6 root 6. Can't simplify the 2 root 6. And over here, the square root of 9 is 3. Multiply by that 5, so I get 15 root 6. Now these are all like radicals, and I can combine all of the numbers in front. So 6 minus 2, that's 4, plus 15, that's 19 root 6. Okay? Number 3. So I've got a lot of simplifying to do in this one. So if you don't want to rewrite it, you could literally split it up like this into the perfect square. So 25 times 5 I know is 125. 27 I know is 9 times 3, where 9 is the perfect square. Here's my perfect square. 20 is 4 times 5. And 48 is 16 times 3. And make sure you are fully simplifying these, okay? Make sure you are fully simplifying these. So what I'm going to do is I'm going to take the square root of the perfect square, so that's 25. So that becomes 5, and it's got to multiply by that negative 2, so that becomes negative 10 root, and then the 5 is left. Square root of 9 is 3. It's going to multiply by that 6, so that's 18, and the 3 is left inside. Square root of 4, that's 2, so that's going to become negative 2, and the 5 is left inside, and the square root of 16 is 4, multiplied by that negative 3, so that's negative 12 root 3. Okay, now I'm going to combine my like radicals. So these two match. So that's negative 12. Root 5 stays the same. And then these two match. So 18 minus 12, that's positive 6 root 3. Since these do not match, root 5 and root 3, you have to just leave your answer as is. Okay. Number 4. I could break up 50 into 25 and 2. This is 9 and 2, and then I can't break up that last one. So the square root of 25 is 5. Square root of 9 is 3. Whatever number you pull out, it's got to multiply by the number in front. So I get 20 root 2 minus 6 root 2 plus 7 root 2. Let's see. So these are actually all like radicals. So 20 minus 6, that's 14, plus 7, that's 21 root 2. Again, the root 2 stays exactly the same. Okay, I promise we're almost done. Just 3 more examples. We got to simplify the square root of 48. That's 16 and 3. Make sure you're fully simplifying. So the square root of 16, that's 4 root 3. And then everything else is already fully simplified. So let's combine our like radicals. That's just these two. So that becomes 16 root 3 minus the square root of 2. And there's my final answer. Okay, number 6. Okay, so we got to simplify all of these. Find a perfect square that goes into 32. That's 4 and 8. But that's actually not the biggest one, so I'm going to change that to 16 and 2 so I can be fully simplified. 50 is 25 and 2. 128, that's 64 and 2. And 28, that's 4 and 7. Notice all of these have a perfect square. Okay? So, the square root of 4 is 16. The square root of 16 is 4. You got to multiply by that 3 that's already out there. So 12, and then the 2 is left inside. The square root of 25 is 5. So plus 25, the 2 is still on the inside. Square root of 64 is 8. So that's negative 8. The 2 is still on the inside. And then the square root of 4 is 2 multiplied by the 5. So 10. And the 7 still on the inside. So the first 3 can be combined and the last one cannot. So 12 plus 25, that's 37, minus 8, that's 29 root 2, plus 10 root 7. And since these aren't the same radicals, you cannot combine them and you leave them as is. Okay, so pause this, do the U-try, make self-check, and then come back and check your work with mine. So the square root of 108, some of you might not have been able to find the biggest one. Let's say you made it into 9 and 12. That's okay. I'll show you what to do from here. I know I can't simplify the square root of 3, and 72 is 36 and 2. So the square root of 9 is 3, multiplied by the negative 2, that's negative 6 root 12. Plus 3 root 3. The square root of 36 is 6, multiplied by the 3, that's negative 18 root 2. So if you get to this point, a lot of us might get stuck and say, oh my god, I can't combine anything, but make sure you are fully simplified. I'm looking at this 12, and I know there is a perfect square that goes into 12. That's 4 times 3, right? So the square root of 4 is 2, so I got to keep simplifying. So this is actually negative 12 root 3 plus 3 root 3 minus 18 root 2. So now I have some like radicals I can combine right here. So that becomes negative 9 root 3 minus 18 root 2. And this is our final answer. Okay, and then you're done. So hopefully you got that. I know this is a lot. I'm really sorry. This is not ideal. But again, if you have any questions, please feel free to email me and I will answer any question that you have.